Have you ever wondered where numbers come from? How did we go from counting with stones to complex mathematical systems that describe both the real world and abstract dimensions? Today, we'll explore the history of numbers, the problems they solved, and the limitations they faced along the way. To understand numbers, we need to go back thousands of years. Around 3400 BC, the Sumerians in Mesopotamia developed the first known numerical system. This system was based on sexagesimal numeration, or base 60. It was invented to address issues in trade and agriculture, such as recording quantities of goods and measuring time. Another significant advancement came from Egypt around 3000 BCE. They developed a base 10 system similar to the one we use today. Though limited, it enabled calculations in trade and construction, allowing them to build the impressive pyramids. However, it lacked positional notation, making complex calculations challenging. As civilizations advanced, the need for more structured systems to solve numerical problems emerged. In Greece, the mathematician and philosopher Pythagoras was among the first to study number theory in the 6th century BCE. The ancient Greeks laid the foundations of arithmetic. Later, Persian mathematician Al-Khwarizmi in 780 to 850 CE was instrumental in creating what we now know as algebra, the art of solving equations and problems using symbols and numbers. In his work, Al-Khwarizmi systematized the rules of algebraic manipulation. Algebra emerged to solve problems in trade and distribution, and to work through equations in multiple steps, something difficult with simple numbers and operations. One of the most important advances in mathematics came from India in the 5th century. Indian mathematician Brahmagupta was the first to define zero as more than just a placeholder. In his work, Brahmagupta explained how to perform mathematical operations with zero, marking a milestone in the history of mathematics. Brahmagupta also introduced negative numbers to represent debts, a revolutionary concept at the time. Although negative numbers were useful for trade and economics, it took centuries for them to gain full acceptance in Europe. As mathematics advanced, the need to express quantities beyond whole numbers emerged. Fractions first appeared in ancient Egypt, where scribes used unit fractions with a numerator of 1, for precise calculations in agriculture and trade. Over time, the Greeks formalized the concept of rational numbers, fractions representing the division of two integers. Fast forward to the 15th century, when European mathematicians faced the intriguing problem of square roots of negative numbers. Italian mathematicians Raffaele Bombelli and Girolamo Cardano worked on cubic equations and discovered the need to think in terms of numbers that didn't exist in the real world. These numbers, called imaginary numbers, were initially controversial but later became essential tools in mathematics and engineering. The imaginary unit, represented as I times squared root of -1, enables the solution of complex equations. Imaginary numbers have since been crucial in fields such as electrical circuits, oscillatory systems, signal transmission, quantum mechanics, and control engineering. In the 19th century, German mathematician Carl Friedrich Gauss revolutionized mathematics with his contributions to number theory, a branch studying the properties of integers. One of his most important works, Disquisitiones Arithmeticae, published in 1801, explored complex numbers and laid the groundwork for modular arithmetic. Gauss solved key problems like theorems on congruences, the law of quadratic reciprocity, and prime number factorization. These ideas are fundamental to modern cryptography and digital security. Thanks to his work, mathematics advanced in areas previously unimaginable. Over time, our understanding of numbers expanded thanks to mathematicians like Georg Cantor in the 19th century. Cantor introduced set theory and demonstrated the existence of different sizes of infinity, a revolutionary discovery that introduced a new type of number. His theory paved the way for new branches of mathematics and a more abstract understanding of numbers. With the advent of modern computing, numbers took on new meaning. In 1937, Alan Turing, known as the father of computing, developed the concept of the Turing machine, which relied on binary numbers, 0 and 1. Today, binary numbers are at the core of all digital technology. From phones to computers, everything operates thanks to this numerical revolution. Numbers have been essential to human progress, from trade in ancient Mesopotamia to fractions in Egypt, zero and negative numbers in India, and imaginary numbers that challenged intuition. Each discovery has brought us closer to understanding the world. Who knows what new forms of numbers might emerge in the future? If you enjoyed this video, don't forget to like, comment, and subscribe for more. Until next time.